Hi, this is Alex from devstories.eu. Apache Cassandra with Python, episode 12 of 12. Large language models are changing how we build applications, but they bring a major storage challenge. When an artificial intelligence model needs context, traditional database queries fail because they look for exact character matches, completely missing the actual intent behind a prompt. Modern artificial intelligence workloads require a fundamentally different way of querying data. That is where vector search comes in, introduced natively in Cassandra 5.0. It is easy to confuse vector search with simple full-text lexical search. A standard full-text index like Lucene is strictly keyword-based. If a user searches your database for the phrase database backup, a lexical search scans for those exact strings. Vector search operates differently. Instead of literal keywords, vectors capture the underlying semantic meaning of your data. A vector search understands that saving a data snapshot or archiving tables relate to the exact same concept as a database backup, even if the words share 0 common letters. To make this work, Cassandra relies on vector embeddings. An embedding is an array of floating point numbers generated by a machine learning model. These arrays act as mathematical coordinates representing the deeper meaning of your text. You store these arrays directly in Cassandra alongside your standard application data. When you need to find relevant content within massive document collections, you perform a vector search. The database compares the vector of the incoming query against the vectors stored in your tables. It calculates the mathematical distance between them. Shorter distances indicate stronger semantic similarity. Consider building an internal chatbot for a large engineering team. You have thousands of pages of technical documentation. An engineer types a question asking how to decommission a staging cluster. First, your application passes that question to an embedding model, which translates the sentence into an array of floats. Next, you send that numerical array to Cassandra as a vector search query. Cassandra instantly scans the multi-dimensional space and retrieves the internal documents whose embeddings sit closest to the question. It returns the correct manual for retiring testing environments because the semantic meaning aligns perfectly, regardless of the differing terminology. This capability is built explicitly for artificial intelligence applications. Most of these applications rely on retrieving highly relevant context to feed back to the language model before it generates a response. By bringing vector search directly into Cassandra 5.0, you eliminate the need to run a separate, standalone vector database. You keep your primary operational records and their semantic embeddings in the exact same distributed architecture, relying on the high availability and scaling Cassandra provides. Since this concludes our series on Apache Cassandra, I encourage you to explore the official documentation and try generating embeddings for your own data hands-on. If you have suggestions for what technologies we should cover next, visit devstories.eu and let us know. Vector search bridges the gap between language and storage, turning complex human intent into a geometry problem that Cassandra can solve at scale. That is all for this one. Thanks for listening, and keep building.